In this quick tutorial, we are going to showcase what Theorem 6 states. This is one of your cyclic quadrilateral theorems, and it doesn't have a proof, so that's the good news. Hi guys, Lever here from Bright Young Brains. So, Theorem 6 basically states that if you have a cyclic quadrilateral and you have an exterior angle, this exterior angle will be equal to this opposite interior angle. That's the law. That's it. Bye. Bruh. Well, I could literally have just done that because that's what the theorem states. So the only key thing now is you want to keep in mind that any Euclidean geometry theorem, especially ones with cyclic quadrilaterals, those have converses. What that means is here we have stated that BCE is equal to DAB. Our reason is that we have an exterior angle for cyclic quadrilateral there. So one other big issue is if you had just a random four-sided shape and then you had to prove that this is a cyclic quad. One of the ways you could prove that this is a cyclic quad is if in some way you prove that an exterior angle somewhere is equal to the opposite interior angle inside that four-sided shape. So with your sixth theorem, again as mentioned, the good news is you don't necessarily have like a proof for it. What you will get though is questions where you have a bunch of lines going everywhere in a Euclidean geometry question, and then within that question they could easily ask you to prove that a portion somewhere you have a cyclic quad. Now if you're going to prove that that tiny portion is a cyclic quad, you would easily be able to do that by using this theorem, by just proving that an exterior angle somewhere is equal to an opposite interior angle somewhere there. So that's what you need to know for the sixth theorem. If you want to go through slightly more complicated theorems, then you can just check in the entire playlist of Euclidean geometry.